There is a lot of learning opportunities behind implementing a JSON parser from scratch. I did it and I want to share with you everything that I've learned in the process. The idea behind implementing a JSON parser is receiving a text in string, in text format, and get this JSON and process that into a programming language object. For example, we have right here an example of a JSON parser in Python. So we get this string and parse that into a Python dictionary with the specific keys and values over here. The first step to implement a JSON parser is to understand the data types behind the specification. Remember that JSON is the acronym of JavaScript Object Notation. So right here we have all the different data types that are supported. So for example, we can have strings, which are encapsulating double quotes. We can have a number, which can be what we understand as an integer or a float, or even scientific notation right here. We can also have Boolean values, which will be true or false. And we have the null, which is the representation of null values. And we have more complex objects like the array, which is a list of different objects, which can be each one of the objects and the types in the list, including another list. So we have this nested characteristic, and also a object, which is just a list of key pair values, what we can call it as a member as well. So for example, with this object, we have the name with the value Leo and the tags, which is a list of tags, and we only have the programming value. Another aspect that is important to understand, it's the rules behind the organization of the data. Because, for example, in order to separate the key and the value from an object member, we have a special character that is used to separate those values. Also, the keys are always strings, so they are encapsulated with the quote symbol over here. And we also can have multiple key value pairs, so we have the comma that is used to separate the different members of that object. So with all those ideas in mind, we have a good starting point to start implementing it. And the primitive types are the easiest one to implement, and I didn't know that as well, that things like the examples right here in that part of the screen, they are also valid JSON, because remember, these are JavaScript object notations, and in JavaScript strings and booleans are also objects. So it's really interesting, because more than 10 years programming, I never seen, for example, in an API receiving a thing like that, but it's part of the specification. And this is a good starting point because we don't have recursion, we don't have those nested objects, so it's pretty simple, for example, to implement the examples that we have right here in the screen. So, as I said, we need to identify which type of object we are working with. So for example, let's suppose the first character that we're working on is the letter N. That means that this is possible a null value. And in the case it's not a null value, it's probably an invalid JSON because it's not a string. Remember that the string needs to be encapsulated with the quotes. The same thing applies to numbers. If we receive a digit, that is probably a number. So we need to parse that and check that. The same applies to the Boolean values, true and false. If we receive the T or an F, that's possible a Boolean value. So we just need to go with the rest of the value to check if it is indeed a true or false, or we are going to raise a validation error. Now that we have all those concepts very clear, we can implement the parser, which is the idea of implementing lists and these nested objects. The implementation, it's not that difficult, but there is some gotchas that we need to understand. Doing that investigation right here is really important, even if you already know that, it's a good idea to remember. So we basically need to scan the entire string. Of course, like white spaces, we can just ignore it. So we are not going to use that. We are just ignoring it. But here's the thing, the first character, that's where we're going to identify which object, similar to the previous explanation. So as we have a left curly braces right here, we know that we're going to parse a object. So if an object is composed of multiple key value pairs, that means that the next character needs to be the key. And if the key is a string, that means that the next character needs to be a quote value. So if we don't have this character right here, that means that is an invalid JSON object, and then you can raise a validation error, a parsing error. The same applies to the next value. So we are going through each one of the characters over here until we find the other quote character, which will mark the end of the key. But as we saw, we have another character that is used to separate the key from the value. So we need to have this character over here. If you had any other character, for example, a number right here, that means that this is an invalid JSON as well, and we would raise a parsing error. And then we would do the same thing for the values and go on until we find the comma. Once we find the comma, that means that we end the key value pairs and we need to go to the next one. We will do the same thing until we reach the array, and once we find the bracket over here, we would apply the rules and the algorithms to parse the specific array. So notice that we have many small different algorithms to parse each one of the objects that we saw in this first list right here, and then we start to combine those algorithms and use recursion and other programming strategies to implement that. It's not my idea to go directly into the implementation details. I will left a link in the description right here that you can see my implementation afterwards and debug and even implement yourself. By the way, if you are liking this video, hit the thumbs up button below. Also subscribing to the channel so you can be notified about new videos, and by hitting the thumbs up you also help me a lot. Continuing. Even though that a JSON is just a data type, is not a programming language, it's also possible to apply some of the strategies that we do with compilers, for example, for parsing programming language, to also parse the JSON value. And I did that, and I could learn a little bit more about the strategies behind implementing parsers, tokenizers, and so on. So my first implementation was very simple, like this general algorithm and idea that we are seeing right now, but the second implementation I actually built a tokenizer and an AST as well. In this second implementation, the big difference that I split into the lexical analysis and also the syntactic analysis. So in the lexical analysis, the idea is to identify which individual token we are going to use. So for example, right here we have this JSON, and we can see that we are going to map each one of the tokens right here into the tokens list. And the function that implements that is the tokenizer. So notice that at this point we're going to ignore all the white spaces, for example, and notice that, for example, the left bracket, the key right here, so that in this case is just a string. Then we have the column, then we have another string, then we have another string for the age, then the column, then the number, and then the right bracket. So at this point with the tokenizer, we are not attribute meaning, like I was saying, key or member or an object or a list. So at this point, we are not applying those rules yet. We are just identifying which one of the tokens, and we are also organizing them in a sorted list, and that's it. So at this point, for example, if we have a token that we don't recognize, like for example the @ symbol, so if we have that in the middle of the JSON or that symbol right here, it doesn't make sense. This is not a valid token. We would raise an error in that case. But we are not going to apply specific meaningful things. So for example, we can have the tokens that we accept, but it could have things like this. So we only use valid tokens, right? Because we have the colon, we have the strings, and we have the brackets. So only valid tokens, but this is not a valid JSON. So that specific rule right here would be implemented in the next step. That's the idea behind the static analysis. So this is also called parsing, but in this world of compilers, we would do this step into tokenizer, parsing, and evaluating, those three different steps. But parsing can be also used as a broad term, as we did in the beginning of this video. So don't confuse with that, okay? And that's the process of getting all the tokens that we processed in the previous step, and we're going to build a tree, this specific structure that we are going to use to validate those rules, right? To check if this is a valid JSON or not. So with this parsing, for example, when we receive those tokens right here, which represents this JSON on top in the comment, these are going to generate that tree data structure. Notice that this is not a regular tree as I have with a binary tree. This is actually called AST. So notice that we have a object node because we have a object data type right here, which are composed by different members, which are the key pairs. And this is organized in a way that has many attributes. It's not abstract nodes. This is pretty similar to what we did when we're modeling business logic inside our code base. So when constructing this AST for the JSON, we also are going to include the terms and all the meaning behind the concepts that we are organizing and validating. Once we got the AST, we can use that to do the final evaluation. That what is going to process it into the programming language object would be, in this case, a dictionary like this one. So why split that process into the tokenize, parse, and evaluate phases? Sounds more complicated, but in fact, from a code maintainability perspective, it's easier to implement in this way. Another benefit of doing that is, for example, once we have the AST data structure right here, if you want to implement a formatter, for example, would be very simpler than with the regular logic. We got some technical issues with the producing of this video, so I'm recording this part again. This is why we are seeing a funny picture of me in the left and not the recording of my face. Anyway, the important part is understanding the concepts and the content of the video, and we have some challenges behind the usage of tokenizing, parsing, and evaluation phases, because we are introducing basically two different data structures. The first one is the list of tokens, and the second one is the AST, the abstract syntax tree. And this is a problem because we need to store those items in memory, so we're going to consume more memory, and as we have separation of concerns, we may have more processing time associated with that. Of course, there is some optimizations that we can do in the sense of the tokenizers. We can only store one tokenizing memory at a time. We can use, for example, we start using Python, use generators to do that. But with the AST, we need to store the entire AST in memory. Not sure if there is a possible implementation to not do that, but that would be complicated as well. So there is a lot of effort and complexity associated with this optimization, which is easier to do in a more simple approach. But here's the idea: having this standard structure behind a programming language or a pattern like JSON, for example, would allow more integrated tools, as we were talking before, like the formatters, the linkers, and everything. And right here, we got a benchmark. This benchmark is for my implementation. So I did two implementations. one with a regular parser, basically doing everything directly, similar to the logic that we checked together in the beginning of the video. And then I did another one implementing the tokenizer and the AST. So we can see over here that the usage of memory between my regular parser and the JSON.loads, which is from Python standard library, it's pretty similar, but with the tokenizer and AST, you consume a little bit more of memory. And regarding time, both of my implementations, it's 10 times worse than the Python implementation. There is a reason behind that, because Python standard implementation relies on C, and why is that faster? Maybe that is a topic for another video, but those are really important points that I'd like to share with you. And that's all for today's video, folks. I definitely recommend you to implement the parser yourself. There is a lot of growing learning opportunities behind that experience, and see you in the next video.